Hello, my fellow chemists. In this video, we're going to take a look at calculating the percent abundance of an isotope. This is labeled as an advanced video because it assumes you have an understanding of the terms atomic mass, mass number, and atomic number, as well as isotope, and that you also are comfortable with some basic algebraic manipulation. If you need a review on those topics, I will put a link in the upper right-hand corner. All right, so let's get started. In isotope questions, it's a very fairly common type of question to ask you to calculate the percent abundance of isotopes. Now, the formula for that is the atomic mass is equal to the isotope mass, the first isotope mass, times that first isotope percentage, plus the second isotope mass times that second isotope percentage. And if there was a third isotope, it would be times that third isotopic mass times the third isotope percentage. So it could just go on and on and on forever. But in our problem here, we're only given 2 isotopes. Now, if we read the problem, it says, if element X has an average atomic mass of 21.78 and exists in 2 stable isotopes, and the 2 stable isotopes are isotope 21, which weighs 21.56, and isotope 22, which weighs 22.08, what are the percent abundances of the 2 isotopes? Now, element X is a hypothetical element that I made up, so you're not going to be able to look it up on the periodic table. So don't be looking up element X on the periodic table. You're not going to find it. So what we need to do then is start off by writing out an equation. So the atomic mass is equal to our first isotope mass times our first percentage for that isotope, what percentage that isotope exists in, plus our second isotope mass times the percentage that our second isotope exists in. And if there was a third and a fourth, it would just go on and on forever. But we only have 2 stable isotopes, so it's just going to stop at 2 terms for this equation here. So we have some of this information given to us in the periodic table. The atomic mass is given to us at 24.78, so we can put that right in there, or 21.78. So 21.78 is equal to, and then the mass of the first isotope is 21.56, so we're given that piece of information as well. Now we don't know the percentage, that's what we're being asked to find, so we're going to make that X. Plus the mass of the second isotope, we're given that as well. The mass of the second isotope is 22.08. 0.08. Now, the second percentage, if you convert these percentages to decimals, let's say that this first percentage turns out to be 70%. We put that as 0.7. Well, that would mean that the second percentage would have to be 0.3, because if you add the 2 percentages up, they would add up to 1. So the second x would then have, or the second percentage would have to be 1 minus x, because 1 minus 0.7 gives you 0.3. So for our second percentage, it's going to be 1 minus x. So now that we have our equation written out so that we have one unknown, so we have one equation here, and we only have one unknown, which is x, we can then just solve for the equation. So the rest of this problem is mostly just algebra. So the first thing that we can do is we can distribute the 22.08 to the 1 and to the x. So what that would lead us to is 21.78 is equal to 21.56x plus 22.08 minus 22.08x. So all I did was I took the 22.08, multiplied it by 1, took the 22.08, multiplied it by x, and that gives us this term here. The next thing that we can do is we can subtract out 22.08 from both sides of the equation. So if I subtract 22.08 on this side of the equation, and then also subtract 22.08 on this side of the equation, what you'll have is this 22.08, they just completely cancel out. And this here, if you take 21.78 minus 22.08, you end up with negative 0.3. And that would then be equal to 21.56x minus, these terms canceled out, 22.08x. All right, we're getting somewhere now. So we have on our left-hand side the negative 0.3. And now on our right-hand side, we can just take 21.56x and subtract 22.08x. If we do that, we get negative 0.3 is equal to, and if you take 21.56 minus 22.08, you get negative 0.52. And that would be x. Now, if we want to just solve for x, you would divide both sides by negative 0.52. So if we do that, x is going to be equal to negative 0.3 divided by negative 0.52. If I divide by negative 0.052 over here, the 0.52 will just cancel out. So now to solve for x is going to be equal to, so all we have to do now is just take the negative 0.3 and divide it by negative 0.52. And that will give us x, and that gives us 0.5769. 0.5769. And if we convert that into a percentage, it would be 57.69%. This 57.69% is the percent for the first isotope, or the isotope that is 21.56, has a mass of 21.56. So the isotope of 21.56 has a percentage of 57.69%. And our second isotope, the isotope that was 22.08, well, if we take 1 minus 0.5769, you end up with 0.4231, so its percentage would be 42.31%. And those are the percents for the two isotopes. The isotope that weighs 21.56 exists at 57.69%, and the isotope with a mass of 22.08 exists at a percent of 42.31%. That's it for this video. I hope you learned something. If you did, don't forget to subscribe and like, and I will see you in the next lesson.